Hi folks, this is chapter 12, part 2. In part 1 we discussed losses. We did not discuss what you should do about them. Most folks are inclined to think if you're making losses, you should shut down immediately. That's actually not the case in most situations. I want to walk you through the logic of how to figure out whether or not you actually are going to shut down or you're going to continue to operate at a loss in the short run. As a brief overview, I want you to start thinking about how you would make this decision. Just because you're making losses doesn't mean you can walk away. So if your business is making losses, you might think, well, I'm just going to quit, which essentially means that you're going to put output equal to 0. Even if you make output equal to 0, you still do not get rid of your fixed costs. Your landlord still wants to get paid, right? They don't care if you're actually working or not. They expect a check for the rent. So really the critical issue is whether or not operating at the best possible Q star, even if it's a loss, will produce a smaller loss than choosing to shut down and make nothing. In order to do this, we're going to need to get our ABC into the picture. We developed the ABC in chapter 11, and the minimum point of the average variable cost is essentially the tipping point. Once your product is not selling for a price it's at least as large as your ABC, then you need to shut down. In fact, you're going to be more or less forced to shut down. If your price is above the minimum of the ABC, then you can make what we call operating losses. These operating losses are going to be smaller than the fixed costs, which you're going to have to pay even if you choose to produce 0 output. So let's take a look at this. Situation in front of us is we've got a price that is actually going to be smaller than our ATC, but it is going to be larger than our AVC once we pick our Q star. So just like always, we're going to head out here and we are going to find the intersection of our MR and our MC and head down and grab our Q star. That's the best Q that we can get, and of course this is our total revenue box. So let's say that we've got 11 for a price, and let's say that our quantity is 300. We're going to be able to come over here and go 11 times 300 for our total revenue, and then we are going to want to subtract out our total costs. In order to make 300 units, we need to plug 300 into our average total cost function. We're going to see that our average total cost of making 300 units is $13. 13 times 300 will give us our total costs. And we got a problem on our hands. We got a problem on our hands because we are going to be making negative $600. We'd have an economic loss of $600, and that would be represented by this area in here. Okay? This loss is going to be an operating loss though, because we are going to actually choose to continue to produce at that. Okay? So operating losses are the losses generating from producing Q star, right? So it's a $600 economic loss at Q equals 300. On the next slide, we'll talk about why, in fact, it's a good idea to operate at a loss here. All right, so we've got the same basic setup here. Our price is still $11. We've already discovered that if we choose to make our 300 units at $11 and an average total cost of $13, then we are going to end up with a negative $600 operating loss at Q equals 300. What happens if we just said, nah, not into it? shutting down, we're going to go to Q equals 0. The reason that we don't want to do that is because we still have fixed costs that we'd have to pay. And in this scenario, I'm going to prove to you that fixed costs are going to give you a larger loss than the operating losses you take by producing at Q equals 300. So, going back to our last slide, we knew that our total costs were equal to 13 times 300, and I want to remind you of an accounting relationship that we learned back in chapter 11. Our total costs are equal to our fixed costs plus our variable costs. Well, if we shut down, we're going to have to pay our fixed costs, but we can get rid of our variable costs. So let's figure out what our variable costs are, and we'll do these variables in purple. We're going to take our 300 and we are going to go up here until we run into our ABC. And when we run into our ABC, we're going to find out that our average variable costs are $8. $8 ABC times 300 units will convert our average into a normal variable cost. Well, what you've got going on here is 13 times 300 for total costs and 8 times 300 for variable costs. So, of course, the difference between total and variable costs is going to leave us with our fixed costs. Okay. So, 5 times 300 is equal to our fixed costs. And another way of seeing this, I want to remind you that the difference between ATC and ABC, no matter where you're at, is always equal to average fixed costs. Well, we're just going to use 300 because that's what we're doing with everything else. And the difference right here is 5. 13 minus 8 is 5, which is where I'm getting this number from. 5 times 1,300 tells you that our fixed costs are equal to $1,500. Now, if we shut down and produce zero output, we still have to pay $1,500. $1,500 is equivalent to our shutdown loss. And of course, $1,500 is greater than $600. If we operate, we only lose $600. If we shut down, we lose $1,500 every single month, or whatever our unit of time that we're measuring over is here. So the moral of the story here is sometimes it makes sense to actually operate at your Q star, right? Our Q star was generating us only a loss of 600. If we shut down, we would have taken a loss of 1,500 here. Don't want to do that. So the question you probably got in mind then is, well, when do we shut down? You're going to shut down when your price reaches the minimum of your ABC. I'll show you that on the next slide. Okay, let's take a look at what happens when your price falls to the minimum of the ABC. What you're going to see here is that your price is actually going to be equal to your ABC, and that means that your total revenue box, your P times Q, is actually going to be equal to your variable costs, because your Q, when you run up and run into your ABC, we'll do it in purple here, this is going to give you an ABC that's equal to your price. So ABC times Q gives you variable costs, right? DC equals Q times ABC. That's going to give you your purple box here. Your green box is your revenue one. And you're going to be able to see that at this Q star, if we plug this into your average total costs, this is going to give you your ATC. Well, ATC minus ABC gives us AFC. And AFC is the difference between ATC and ABC. It's this guy here. Well, that height by that blue bracket is equal to your AFC, and an AFC is going to multiply by Q star again here, and this will give us our fixed costs. So what we've basically got going on here is the blue box plus your purple box is going to add up and equal your red box. So it looks like this essentially. Here's your ATC. Part of that is fixed cost, and part of that is variable cost. Well, we know that your green revenue box is large enough to cover your variable costs. It's not covering any of your fixed costs though. Your fixed costs are what you earn if you shut down. So if you can't cover any of your fixed costs, then the loss that you're going to take by operating is equal to the same loss you'd take if you shut down. You may as well just shut down. Now if your green box actually falls even lower because your price falls, then you're not covering your fixed costs, you're also not covering all of your variable any longer anymore, this area in here. The point that I'm making is that if this P falls below the minimum of the AVC, you want to shut down. In fact, it's pretty much impossible to keep operating. If you can't pay your variable costs, you're bouncing payroll checks and you're not paying your vendors. No one's going to work for you and no one's going to give you any more inputs. So, keep that in mind. One last thing that I want to cover here is going to circle back and talk about our bigger project of how utility theory of value is trying to explain prices. We knew that the demand curve was essentially coming from our consumer, right? Our individual marginal utility curves were helping us decide when we'd purchase and at what prices we'd purchase. So in this last slide that we were just on, I hope you realize that the curve that we kept referencing again and again and again was our marginal cost curve. We kept looking at the market price, seeing where it intersected with the marginal cost curve, and that was essentially generating our quantity supply. And the only part of that marginal cost curve that we were actually willing to produce at was the portion that was above the minimum of our AVC. So what we're really talking about then is that our marginal cost curves above the minimum of the AVC is really our individual firms' supply curve. So if we understand how we get individual firm supply curves, all we have to do is add them all together to get to a market. So we've got a supply curve and a demand curve for the market, and of course supply intersecting with demand is where we find our equilibrium prices. So utility theory of value believes they have a price theory about why prices are what they are. It's a reflection of consumers and firms engaging in maximizing behavior. Firms and consumers are both making decisions on the margin and following the golden rule. Their behavior leads to market equilibrium prices. Okay, I think that'll probably do it for chapter 12. There's some other good stuff in there that I want you to make sure you read, but these are the major points.